All right, the ideal gas equation. This is the big equation for this gas section that we're covering here in Unit 2. And the equation, as you can see here, is PV equals nRT, where P is the pressure. Now, in this case, we've got to be very careful here because P is the pressure, and whenever you use the ideal gas equation, the pressure must be in atmospheres. V is obviously the volume. The volume must be, for the ideal gas equation, must be in liters. N is the new part of this. Why they use the letter N, I don't know. But N is the moles. And so obviously N is measured in moles. For example, if they give you the grams of something, you have to use the molar mass. Molar mass, and convert those grams to moles. And that's, you have to use moles here. T is the temperature, similar to Charles' law. You have the temperature must be in Kelvin. If it's not, you got to put the pressure into atmospheres, you have to put the volume into liters, and you have to put your temperature into Kelvin. And again, if they give you grams, you have to convert those grams to moles. Okay, R is the gas law constant. Okay, and it is equal to, so R equals 0.08206 liters atmospheres over Kelvin mole. Okay, and that does not change. You can change the units on it, but that does change the value here. But again, that is the value that we typically use on the AP test. This equation is given on the equation sheet. If you look at your equation sheet, you'll also notice on the side they do give you the value of R. They also tell you that P is pressure, V is volume, etc. Okay, let's look at some examples with this. Example number 1, you've got some ammonium chloride. It's going to get heated. You're going to make some ammonia gas and some hydrogen chloride gas. So it says a 10-gram sample of solid ammonium chloride is placed into a rigid 3-liter container that's sealed and heated at 575, producing 3.18 grams of ammonia. Calculate the pressure of ammonia once all of that NH4 has been decomposed. So we know we're going to start with PV equals nRT. We're then going to take that equation, and they want us to solve for the pressure, so we've got to find P. So that means we've got to get P by itself, so P is going to equal nRT over V. So N is the moles, so we have 3.18 grams of ammonia. Now watch how I do this. I'm just going to take 3.18, and I'm going to divide by the molar mass of ammonia. So I go to the periodic table. I see that it has a molar mass of 17, and then I'm just going to write the word mole in there, okay? Because by taking 3.18 grams and dividing by 17, that gets me to moles. I don't even care what the answer is of that. I'm just going to use that in my problem once I get to the math, to the calculator part. And then I put the R value, 0.08206 liters atmospheres, watch how I do this, over Kelvin mole. You'll see why, and that is the correct way to do that. Notice up here when I wrote it, it's liters atmospheres on the top, Kelvin mole on the bottom. If you put R on the bottom, then you put liters atmospheres on the bottom and the Kelvin mole part on the top. Okay, and then we've got the temperature. It does say 575, and that's already in Kelvin, so we're good there. And then the volume is a 3-liter container. Now, if I have this set up correctly, this is a great way to check to see if you have it set up correctly. Cancel your units that can cancel. For example, I have moles on top, I have moles on the bottom, they cancel. I have liters on the bottom, I have liters on the top, they cancel. I have Kelvin on the top, I have Kelvin on the bottom, they cancel. I'm left with the units that the question is asking me for. So now I can just go to my calculator, and I can go 3.18 divided by 17, and again it says 0.187, don't care, times 0.08206 times 575 divided by 3.0 equals 2.94 atmospheres. Okay, and that is just a basic average ideal gas equation type question. You should be able to solve for pressure, for volume. If they give you grams, you've got to be, or if they ask you for the grams, you have to be able to get moles. So start with PV equals nRT. How would you get N by itself? You would divide by R and T. So you'd end up with N equals PV over RT. Once you did that and got the moles, then you would take the moles and then you'd go moles, and then you'd use the molar mass. In 1 mole, there's how many grams based on the periodic table. Put that number in here, and then you'd get your grams. Okay? And then obviously you've got to be able to find temperature as well. So, lots of different variables: pressure, volume, moles, and temperature. Notice that this equation is not the equation you use when the pressure changes from one thing to something else, or if the temperature changes from 70 Kelvin to 175 Kelvin. Okay, that's when you use some version of the combined gas law. This is just, here's the volume, here's the pressure, here's the temperature, find the moles. Or here's the moles, here's the temperature, here's the pressure, find the volume. Okay, that's when you use this equation. Okay, now again, it's given on the equation sheet. It's very useful for answering problems involving pressure, temperature, volume, moles, things like that. Okay, and again, a lot of what I already discussed is right there, so you can read that. Okay, now 2 of the equations that you can find are these equations right here, using the ideal gas equation. Okay, is you can find the density of a gas. So one of the ways, as we know, to find density is equal to mass over volume. But a lot of times they won't give you the mass or the volume, but they will. They'll give you the pressure. They'll give you this big M here, and this big M here stands for molar mass, and then R, that same gas constant, and then T, the temperature in Kelvin. Okay, you could take the pressure, multiply it by its molar mass, divide by R, and divide by T to get the density of a gas. So, well, which equation do I use? Well, if they give you the mass and the volume, absolutely use this equation. Okay? If they don't, and they give you pressures and temperatures, and that you know what formula it is, and you can find its molar mass, then of course, you're going to use this equation. Okay? Now, these 2 equations are not given on the equation sheet, so we have to come up with some stupid way to remember them. So the way I remember the density equations, I think of density equals nighttime, like instead of AM, you're in the PM, so PM, and so it's nighttime over right time. Okay, RT, right time. So nighttime over right time is how I remember the density equation. And then for this one, capital M, which is molar mass, just like in the other equation, molar mass is equal to the density times the gas constant R times the temperature divided by the pressure. Okay? Or I think of it as molar mass equals dirty, DRT, and then P on the bottom, so dirty P. Okay? So molar mass is the dirty P equation is how I remember it, and then the density equation is the nighttime over right time. Okay, so let's look at an example with this. A compound has an empirical formula of CH2Br, so we remember that empirical formula sometimes isn't the real formula, it's just the ratio of the elements to each other in the formula. Has a vapor density of 6 grams per liter, 375.93. Use this data to determine the molar mass of the compound. So molar mass is the dirty P equation, dRT over P. What if they don't give you the density, but they give you the mass and the volume? Then you use that right here. You put the mass on the top, you'd put the volume on the bottom, and guess what? Then you have your density. In this case, they actually give us the density, which is 6, so 6.00 grams. Again, notice how I write this, over liters. Because remember, guys, we're trying to find the molar mass. What are the units of molar mass? What are the numbers, the units on the periodic table? It's grams per mole. So if we've done this correctly, guess what? The units we should have left are grams on the top and moles on the bottom. Okay, so R is 0.08206 liters atmospheres, Kelvin mole. The temperature is 375 Kelvin. And the pressure is, again, it doesn't matter where you put it, 983 ATM. Again, lots of units going on here. So again, let's go through. How do we know we have it set up correctly? If we have our units left over correctly. So liters and liters cancel. Atmospheres, atmospheres cancel. Kelvin, Kelvin cancel. Notice what we have left. We have grams left on the top. and moles left on the bottom. That's why units are so helpful. I hated them too when I was learning how to do this, but they're really, really helpful. So then we just go 6 times 0.08206 times 375 divided by 0.983, and I get right around 188 grams per mole. Okay, so that's part 1, is finding the molar mass, and then part 2 says what's the molecular formula. The molecular formula, remember, is the real formula. So we take our empirical formula and we use the mass of it to figure out what do we multiply that number by to get to 188. So what does CH2Br, what's its mass? Where's a periodic table? That's a better question. So bromine is right, again, you don't have to be perfect on this, but right around 80. So carbon's 12, so that's 92. 80 plus 12, 92. Plus another 2 is 94. So this has a mass of 94. 94 times what number equals 188? It's times 2. So that means that the molecular formula is we're gonna multiply everything in that formula by 2. So C2H4Br2. Okay, and then our final one here for today deals with standard. You know what? Let's go ahead and stop right there for now. So we're going to do we're going to practice the ideal gas equation. We're going to practice the molar mass and density equation, and then in our next video we'll talk about standard temperature and pressure.